There is a cave cut into a hillside on the Red Sea coast of Egypt, and it was sealed shut with two enormous limestone blocks. Inside that cave, buried in the sand right at the entrance, somebody left a stack of paperwork. Not scripture, not prayers, paperwork. It is a work log, day by day, laid out in two columns like a shift schedule, written by hand by a man who supervised a crew of around 40 boatmen and reported to a manager above him. It records where his team slept each night. It records what they loaded and where they loaded it. It records how long each trip took, and it records, over and over again, the name of the place they were delivering to. Akhet Khufu, the horizon of Khufu, the Great Pyramid of Giza. For 100 years, we have been told nobody knows how the pyramids were built. That is not true anymore. Somebody wrote it down while it was happening. His name was Mirror. His title translates as inspector, and the pages he left behind are the oldest inscribed papyri ever recovered in Egypt. They survived because they were abandoned in a sealed cave in the desert and then forgotten for 4,500 years. And the very first thing they tell us should not be possible. Mirror's crew did not drag stone across the sand to Giza. They sailed it. 2 or 3 round trips every 10 days, loaded with white limestone, delivering to a harbor at the foot of the pyramid plateau. There is no water at Giza. There has not been water at Giza for thousands of years. The river today sits kilometers away across a floodplain full of farmland and apartment blocks. Mirror's log describes tying up at a basin beside the largest building on Earth, unloading 2.5-ton blocks, and casting off again the next morning. Which means one of two things. Either the oldest written record we have of the pyramid's construction is wrong about the single most basic fact of the operation, or the landscape around the pyramids used to look completely different, and we lost it. In 2024, a geomorphologist pointed a radar satellite at the desert and found out which one. That is the first of 3 things this investigation is going to lay out. The second is a piece of hauling machinery discovered in a quarry in 2018 that works at an angle engineers had spent decades insisting was impossible. The third, published in 2024 and still being argued about, is the one that changes the entire question, because it suggests that the oldest pyramid in Egypt was not built with ramps at all. It was built with water pressure, a machine with no moving parts made of stone and gravity, hidden in plain sight for 4,500 years, while everybody stood on top of it taking photographs. And at the end of all this, there is a space inside the Great Pyramid that we know exists, we have measured, we have looked into with a camera on a wire, and no human being has entered since it was sealed. Start with the thing everyone has already seen and nobody looked at properly. There is a painted wall in a tomb in Middle Egypt, in a place called Deir el-Bersha. It belonged to a provincial governor named Jehuti Hotep, and the painting shows one enormous alabaster statue mounted on a wooden sledge. In front of it, 172 men are hauling on ropes in 4 long lines. Every detail is labeled. It is the single most complete picture we have of how ancient Egyptians moved something heavy. And standing on the front of the sledge, right at the leading edge of the runners, is a man pouring water onto the sand. For more than a century, that man was explained away. Egyptologists interpreted the water as a purification rite, a blessing, a ceremonial gesture to sanctify the ground the statue was crossing. Symbolic, religious, meaningless in engineering terms. It is in the standard literature that way for generations. Then in 2014, a physicist at the University of Amsterdam named Daniel Bohn read the painting as an instruction rather than a hymn. His team built miniature sledges, filled trays with sand, and measured the force needed to pull a load. On dry sand, the grains crumble and pile up in front of the runner, and you are effectively pushing a growing hill of sand ahead of you the entire way. Add water in the right proportion, roughly 2 to 5%, depending on the sand, and the grains bridge together. The surface stiffens. it stops piling. It behaves less like a beach and more like a road. The pulling force dropped by half. Half, which means the man standing at the front of that sledge with a jar in his hands was not blessing anything. He was doing the job of 86 men. The paper went into Physical Review Letters, one of the most rigorous physics journals in the world, under the title Sliding Friction on Wet and Dry Sand. For over 100 years, scholars looked at a painted engineer and saw a priest. That is the pattern this entire story runs on. And once you see it, you cannot unsee it. Egyptian records do not separate the practical from the sacred the way we do. The instruction and the ritual are written in the same sentence, in the same tone, with the same seriousness. So when we go looking for technology in the record and find religion instead, the mistake is almost never theirs. It is ours. Which brings us back to Merer's impossible harbor. Here is what his log actually says, and the plainness of it is the point. Day 25, his team spends the day hauling stone at Tura South. Day 26, they cast off loaded with stone for Akhet Khufu and spend the night at a place written as Shi Khufu, the basin or lake of Khufu. Day 27, they sail from Shi Khufu to Akhet Khufu, still loaded, and spend the night at the pyramid. Day 28, they cast off in the morning and sail back upriver. Day 29, they are hauling stone at Tura again. It reads like a delivery driver's timesheet, because that is exactly what it is. The papyri were found in 2013 by a French mission led by Pierre Tallet at a Red Sea site called Wadi al-Jarf, tucked into the entrance of man-made galleries used to store dismantled boats. They date to the 26th or 27th year of Khufu's reign, which, by every estimate, is the very end of it, the period when the outer casing of fine white Tura limestone was going on. Each boat could carry something like 70 to 80 tons, around 30 of the casing blocks. 2 or 3 round trips per 10-day week works out to roughly 200 blocks a month. Not legend, not inference, invoices. But a boat needs water, and Giza is dry. So for years, the log sat in a strange position, universally accepted as authentic and quietly impossible to reconcile with the map. In May 2024, a study came out in the journal Communications, Earth and Environment, led by Emin Ghonaim of the University of North Carolina, Wilmington. Ghonaim grew up in Egypt. She had spent her career studying landscape and flood topography, and she had always wondered why 31 pyramids were strung along one narrow, waterless, inhospitable strip at the edge of the Western Desert. She started with radar satellite imagery because radar penetrates dry sand and returns the shape of what is buried underneath. Then, multispectral imagery. Then elevation models built from the satellite radar data. Then ground-penetrating radar and electromagnetic tomography on foot. Then 2 deep soil cores drilled straight down. At about 25 meters below the modern surface, the drill came back with sandy river sediment. They had found a lost branch of the Nile, 64 kilometers of it, running along the foothills of the Western Desert Plateau, buried under farmland and desert, between 200 and 700 meters wide, in places half a kilometer across and over 80 feet deep. They named it the Aharamat branch, from the Arabic word for pyramids. 31 pyramids sit along it, spanning nearly 1,000 years of construction, from the 3rd dynasty down to the 13th. Giza sits about a kilometer from where its bank ran. And then comes the detail that turns a geological survey into a confession. Many of those pyramids have a causeway, a long raised ceremonial walkway leading down from the monument. Egyptologists had cataloged them for a century as processional routes. Ghanem's team found that the causeways run perpendicular to the vanished river and terminate directly on its bank, ending at the structures we call valley temples. Those valley temples were not just temples, they were docks. The causeway is not a religious road. It is an unloading ramp from a port. The pyramid complexes were laid out around a working waterfront, and when the river migrated east and silted up, probably driven by the great drought that began around 4,200 years ago and the wind-blown sand that came with it, the harbor logic vanished and left only the ceremony behind. Merer was right. We had simply lost his address. If you want more investigations like this one, where the paperwork survives and the landscape confesses, subscribe, because this is the kind of evidence that never makes the documentaries. So the stone arrives by water. That solves the transport of 2.3 million blocks across 90 kilometers from Tura, and the granite from Aswan, roughly 900 kilometers upriver. Some of those beams weighing between 25 and 80 tons. Now comes the part that has broken every reconstruction ever attempted: getting it up. The Great Pyramid rose to about 146.5 meters. The standard answer has always been a ramp, and the standard answer has always had a problem that its own defenders admit. Build a straight ramp at a gentle, comfortable grade of around 7%, the sort of slope a hauling gang could actually manage with a loaded sledge. And to reach the top, you need a ramp more than 2 kilometers long. That ramp would contain a volume of material comparable to the pyramid itself. You would be building a second monument in order to build the first, and then dismantling it and hiding every trace. At Giza, there is no trace. There is no quarry gap for it, no debris field, no footprint. So the ramp has to be steeper. And for decades, the objection was that a steep ramp is useless because a hauling team on a slope loses the leverage to move a multi-ton sledge before you reach any angle that solves the geometry. Then, in 2018, an Anglo-French mission working at Hatnub found the machine. Hatnub is an alabaster quarry in the eastern desert, roughly 65 kilometers southeast of modern Minya. It is the most prestigious source of that milky banded white stone in Egyptian history, and it is extraordinarily well preserved, still covered in inscriptions left by the expeditions that worked it. The joint team from the University of Liverpool and the French Institute for Oriental Archaeology in Cairo, co-directed by Roland Enmarch and Yannis Gordon, uncovered a haulage system leading up out of the quarry. It is not a plain ramp. It is a central ramp flanked on both sides by staircases, and both staircases are lined with dozens of post holes. That configuration is the whole answer. You put your block on a sledge on the central ramp. You run ropes from the sledge around the wooden posts standing in those staircases. The teams stand on the steps on either side, above the load, and haul. The posts are not scaffolding. They are the working part. Wrapped rope around a fixed post is a force multiplier, and the men above are pulling with their body weight, assisting instead of fighting them. Gordon's assessment was blunt. With that system, they could pull heavy alabaster blocks out of the quarry on slopes of 20% or more, roughly 3 times steeper than the gentle ramp everyone had been modeling. And nothing like it had ever been found anywhere else in the ancient world. Then they examined the tool marks and read the inscriptions, and found 2 of Khufu's. The dating puts this system in the reign of the man who commissioned the Great Pyramid, which means, at minimum, that during the construction of the Great Pyramid, Egyptian engineers already knew how to move multi-ton stone up slopes far steeper than modern reconstructions allowed them. Suddenly, a short, steep ramp fits on the plateau without a phantom second monument attached to it. That is clue 2, and it is solid, published, and physically present in the ground. Now we get to the one that nobody in the field has finished arguing about. And the reason is that it does not just adjust the model, it replaces it. To find it, you have to go to Saqqara, and you have to go earlier than Giza, back to the Step Pyramid of Djoser, around 2680 BCE. The oldest colossal stone building in Egypt, about 60 to 62 meters tall. The first pyramid, the first monument built entirely of dressed stone masonry, and the debut of the whole idea. Its architect was Imhotep, and later Egyptians deified him which is not something they did for administrators. The Saqqara Plateau around it is littered with structures nobody has ever satisfactorily explained. The largest is called Gisr el-Mudir, a colossal rectangular stone enclosure a few hundred meters from the pyramid, big enough to hold several football pitches. For a century, the explanations were placeholders. Cattle pen, unfinished enclosure, fortress. Nobody was satisfied because none of it explains the engineering effort involved. And then there is the dry moat, an enormous trench cut into the rock encircling Djoser's complex. And in its southern section, a monumental rock-cut structure made of successive deep compartments in a line. Also unexplained. Also enormous. Also apparently pointless. In August 2024, a study published in PLOS One by Xavier Landreau of the CEA Paleotechnic Institute in France, working with hydrologists, engineers, and material scientists from INRAE and the University of Orléans, mapped the watersheds around Saqqara using satellite radar and the old survey archives, and proposed that all of these structures are one machine. Start with the water. West of Saqqara runs a dry channel called the Abusir Wadi, which once carried runoff down from the higher ground toward the Nile. Satellite imagery shows that Gisr el-Mudir does not sit near that channel. It sits across it, deliberately intersecting the bed. That is not an enclosure. That is a dam. Specifically, what a modern engineer would call a check dam, a structure built across a seasonal watercourse to slow the flow, hold back water, and trap the boulders, debris, and heavy sediment that a flash flood carries. Every time the wadi ran hard, Gisr el-Mudir filled and settled out the rubbish. The topography beyond it suggests a temporary lake could pond west of Djoser's complex, and water could then run into the dry moat surrounding it. Now, the compartments. Landreau's team read the southern section of the moat against the requirements of a modern water treatment plant, and it matches, compartment by compartment. A settling basin, a retention basin, a purification stage, water passing from one compartment into the next, dropping its sediment and turbidity at each step, arriving at the end clean. Together, the paper argues, the dam and the trench form a single hydraulic system that captures floodwater, controls its flow rate, and clarifies it. And then it goes somewhere else entirely. Because inside the Step Pyramid, there are two vertical shafts that have never had a convincing purpose. The team's proposal is that treated water was fed into those shafts, and that the shafts worked as a lift. You float a wooden platform in the shaft. You load a dressed block onto it. You raise the water level, and the block rises. You feed it out at the working height, drop the level, and the platform comes back down for the next one. Stone lifted up through the center of the pyramid in what the authors describe as volcano fashion, rather than dragged up the outside of it. No pulleys, no cranes, no mechanism to wear out. The lifting force is the weight of the water itself, and the entire apparatus is a hole with a float in it. Read the sequence again, because the audacity of the claim is in the order of it. Trap a flash flood in the desert. Filter the sediment out of it through a purpose-built rock-cut plant. Pipe the clean water into the interior of the monument you are building, and ride your masonry upward on it. If that is what happened at Saqqara around 2680 BCE, then the first pyramid in history was not raised by muscle alone. It was raised by hydraulic engineering, roughly 4,600 years before the word existed. The authors are careful, and the caution matters. They call it a possible use of hydraulic force. They say more work is needed on how the water moved through the shafts, and how much of it was actually available in a given season. Plenty of Egyptologists think the water budget will not support it, and that the shafts have a funerary function instead. That argument is live and unresolved as of right now. But the dam is a dam. The compartments do what a settling and purification system does. Those two structures had no functional explanation at all before this, and now they have one that ties them together. Here is where it gets stranger. because Djoser is not the only pyramid with unexplained internal space. The Great Pyramid of Khufu is the most examined building on Earth, and until recently, the assumption was that its interior had been fully mapped since the 19th century. Then, a project called Scan Pyramids started imaging it with cosmic rays. The method is beautiful and completely non-invasive. Muons are particles produced when high-energy cosmic rays strike the upper atmosphere, and they rain down constantly through everything, including 140 meters of solid limestone. Dense stone absorbs more of them. Empty space absorbs fewer. Put detectors inside the pyramid. Count muons arriving from every direction over months, and you can build a density map of the whole structure without moving a single block. 3 separate teams used 3 different detector technologies. Film plates from Nagoya University, electronic detectors assembled piece by piece inside the Queen's Chamber by a team from Keck in Japan, gas telescopes outside from France, aimed at the mass. In 2017, they announced a cavity above the Grand Gallery with a cross-section comparable to the gallery itself and a conservative minimum length of about 30 meters. They named it the Big Void. It was the first major internal feature reported inside the Great Pyramid in over a century. Then they went after a second anomaly behind a feature on the north face called the Chevron, a set of 4 enormous limestone blocks set in 2 inverted angles above the original entrance. In March 2023, in Nature Communications, a team including Sébastien Procureur of Université Paris-Saclay published a precise characterization. A corridor about 2 meters wide and 2 meters high, beginning about 0.8 of a meter behind the chevron and running roughly 9 meters into the pyramid. Cairo University and the Technical University of Munich cross-checked it between 2020 and 2022 with ground-penetrating radar and ultrasonic testing, and confirmed a strong air anomaly exactly where the muons predicted. 1. Then they slid an endoscope through a joint between the stones and got a picture. A corridor with a vaulted ceiling, sealed since construction. And nobody knows what it is for. Here is what is interesting about both of these spaces, and it is the opposite of what you would expect. Almost no Egyptologist thinks they are hidden treasure chambers. The prevailing view is that they are structural or constructional, relieving space to redistribute load. Or, and this is the possibility that connects everything, the leftover architecture of how the thing was built. Because there is a long-standing proposal, argued most persistently by the French architect Jean-Pierre Houdin, that a substantial part of the Great Pyramid was raised by a ramp running upward inside the pyramid, spiraling within the outer casing, invisible from outside because it was inside the whole time. He did not invent that idea from nothing. In 1986, a French team from the National Electricity Utility ran a microgravimetry survey across the structure, measuring tiny variations in density, and reported a lower density anomaly winding upward through the mass in something like a spiral. Nobody has ever opened it up to check. That survey drilled a small number of holes, found fine sand in one cavity, and the follow-up never came. The Big Void has been known since 2017 and has never been entered. No permit has been granted to drill into it. Officials have publicly characterized voids in the pyramid as unremarkable, on the grounds that a structure assembled from more than 2 million blocks contains gaps everywhere, and that reading meaning into them is speculation, which may be entirely correct. It is also, functionally, a decision not to look. So we have a monument with at least one 30-meter cavity in it, a 9-meter sealed corridor we have photographed but not walked, a decades-old density anomaly that traces a spiral through the mass, and a construction question that any one of them could answer. And the equipment to check is non-destructive and already on site. Now, does any of this prove that the pyramids were raised by lost technology or by knowledge that came from somewhere other than Egypt? No. It proves the opposite, and the opposite is more impressive. Everything we have found points in one direction, and that direction is administration. We know where the crews lived. South of the Sphinx, at a site called Height El Ghurab, excavations directed by Mark Lehner uncovered an entire planned settlement, laid out in long galleries where work gangs slept in rotation, with bakeries built around huge, bell-shaped bread pots, and animal bone in quantities implying a supply chain moving cattle, sheep, and goats in from estates across the country to feed thousands of people every single day. This was a state logistics operation with a menu. We know how they organized labor because the crews signed their work. Painted gang names survive on blocks inside the pyramid, in the spaces above the king's chamber where nobody was ever supposed to read them. One of them calls itself the Friends of Khufu. These were rotating work teams with identities and rivalries, not anonymous masses. We know they were cared for because skeletal remains from the workers' cemetery show healed fractures, breaks that were properly set and allowed to mend. Somebody with medical training was assigned to the site. We know they had mathematics for exactly this problem. There is a papyrus of arithmetic problems in which a scribe calculates the slope of a pyramid from its base and its height using a unit called the seked, palms of horizontal run per cubit of rise. It is a written formula for pyramid geometry. They were not eyeballing the angle. They were computing it, and we know the survey work was extraordinary. The Great Pyramid's base is aligned to true north with an error better than 4 minutes of arc, about 1/15 of 1 degree. Khafre's is off by about 6 minutes. Snefru's Red Pyramid at Djoser by about 8.7. Here is the detail that gives it away as human. All three are wrong in the same direction, rotated slightly counterclockwise, by amounts that decrease over time as the builders got better. The engineer and archaeologist Glenn Dash worked out how. Plant a vertical rod in the ground on the day of the equinox and track the tip of its shadow. On the equinox, and only on the equinox, that shadow tip runs in a straight line, and that line runs almost perfectly east to west. Almost. Dash set up a rod on a wooden platform on the autumn equinox of 2016, traced the shadow, drew the line, and found it landed with a small counterclockwise error. The same magnitude, the same direction, the same fingerprint as the pyramids. The most precisely aligned monuments of the ancient world may have been oriented with a stick, a piece of string, and one correctly chosen day of the year. That is the grounded version. No lost civilization, no forgotten machines from elsewhere. Instead, a river highway that has since disappeared under farmland, sand-wetted to a measured stiffness to have friction. Ropes wrapped around posts to beat a slope everyone said was unclimbable. Possibly floodwater filtered and used as a lift. Gangs on rotation, a bakery, a doctor, a formula, and a shadow. Now run the numbers on what that added up to. 2.3 million blocks, roughly 20 years, 10-hour working days. That is about a dozen blocks set every hour for 2 decades without stopping, while the alignment held to a 15th of a degree and the casing joints closed to a fraction of a millimeter. There is no single trick that does that. It is a supply chain, a workforce management system, a survey discipline, a materials operation, and a set of mechanical solutions, all running simultaneously for a generation. That is not a mystery about muscle. It is the earliest large-scale industrial project on the human record, and it happened in the Bronze Age, which leaves the chapter we still do not have. If the first pyramid was raised on water, somebody worked out the hydraulics, tested them, and refined them across generations at Medum, at Djoser, at Giza. That knowledge existed. It was taught, and then the technique was abandoned, the vocabulary was lost, and the only record we have left of it is the shape of the holes it left in the ground. That is what makes the sealed spaces so hard to walk away from. Not treasure. Method. If a construction system was left inside the Great Pyramid when the casing went on, then the answer to the oldest question in archaeology is not missing. It is enclosed, and it is still there. 9 meters of corridor behind 4 angled blocks on the north face, vaulted, empty, and lit exactly once for a few minutes by a camera on a wire. 30 meters of cavity above the Grand Gallery that no one has been permitted to enter. A spiral of low density winding up through 2 million blocks that has been on a survey chart since 1986 and has never been checked. 4,500 years of tourists have stood on the outside of that building. The instructions may have been on the inside the whole time. Watch the next investigation on screen now.